Okay, let's take a look at some example problems from Chapter 6, which is dealing with probabilities and localized probabilities to just the normal distribution. So one of the ideas that we have in terms of the normal curve, so if we drew a simple graph, a simple bell curve, sorry, that's not very good. The normal distribution is centered on the mean with 50% above and 50% below. And so when we're looking at the probabilities for the standard normal curve, we're going to be centered on 0. Okay, and what we can do to answer the questions coming in terms of probabilities, we're going to draw pictures, and I think that really helps to just kind of visualize what's going on. Okay, so let's take a look at first number 8. And in this example, we want to compute some probabilities of a z-score falling within some range values. Then I want to look at some other examples, 10 and 16, and kind of look at how do you take, for example, if you knew the probability, how would you come up with the z-score? And then also if you had just some values coming from another normal distribution, how would you first standardize them and then compute the probability? Okay, and again, I want to let you pause the video and kind of practice some problems just to double check this to verify that you know what's going on and give yourself some encouragement that you've got this stuff figured out. All right, and number 8, we have a normal distribution that's the unit normal. So the we're talking about the z, so mean of 0 and standard deviation of 1. Let's go ahead and find the probability that a z-score lands between negative 0.8 and 0.8. Okay, so let's draw the picture first. Here we go. It's centered on 0, and we're looking at 0.8 and negative 0.8. And so let me switch colors here. We're looking to find the area. That's how we're going to measure the probability. Really what we're doing is we're finding the proportion of values out of the whole that land in between these two z-scores. And so we're going to compare the area occupied here to the area of the whole, which by the way is 1. And so what we can do, and let's see how this will work, we could switch over to the table B.1, which is in the back of our book off the top of my head. I don't know the page number. But here it is, and what you notice is that, well, let's see, how can I interact here? We have a column on the left. This is the z-score. Okay, and so what we're going to do is find those z-scores in the left column, and then we're going to find the probability. And so we have 3 different pictures to look at. This is a kind of not very nice scan from our book. We're looking for the picture that we have is kind of similar to this. We're going to start at 0 and go up to that first z-score and then down to the first z-score. And since this is a symmetric distribution, notice there's no negative signs, but it's okay. We're going to find 0.8 in the field. So on the left hand side we have 0.8, and then we're looking for this column over here, column C, which is the proportion between the mean and z. So 0.8, so 0.2881. That's telling us between 0 and 0.8 there's approximately 28% of the values there. So let's switch over to our picture. We computed here that between 0 and 0.8 there was approximately 0.2881 so that's the proportion of scores. But if we notice that this is a symmetric data set, that means from 0 back to negative 0.8, that's also 0.2881. So to answer the question up here, it's just going to be twice this. In other words, we're going to take the full set of this, which is just the sum of 0.2881 and 0.2881. So that's going to be twice 0.2881, which is equal to 0.5762. Okay. Let's take a look at another example. So again, we have the probability or the proportion of z-scores landing in between negative 1.2 and negative 0.8. So again, let's draw the picture first. Hopefully you can draw better than me. Here's 0. Here's negative 0.8. And here's negative 1.2, and what we're looking for is the region in between these two. So we're looking for this area. Okay, notice that on the table, any of the pictures, there's no kind of intermediate band except for this one, which is centered on 0. So ours is offset, and what we want to do then, if I switch back over here, what we want to do then is compute the full area So I'll do this in a different color. We want to compute the full area of negative 1.2. We want to compute all of this. And then what we want to do is subtract this small region in here. So we're going to subtract to get the total. So let's flip back over to the table. So negative 1.2, that means we're going to find 1.2 in the field on the column here. So z 1.2, and we're going to go between the mean and that z-score. So 0.3849. So right here we have 0.3849. So that means 38% is occupied in this zone. And then to find the other one, 0.8, well, we actually just did that one. So that one, this region right here was 0.2881. And when I take the difference in these scores, in other words, 0.3849 minus 0.2881, I get a probability of 9.68. So in other words, we're saying that 9.68% of the z-scores land between negative 1.2 and negative 0.8. Okay. So let me pause and let you practice one or two. Okay, let's take a look at problem number 10, also in chapter 6. So number 10. In this one, let's look at kind of the reverse picture. If we had a particular region shaded in, could we find the z-scores? Okay, so find the z-score location of the boundaries separating, and I'll give you some different conditions here. So separating, and let's do this first one, the middle 40% from the 60% in the tails. As a heads up, you'll probably hear my son talking in this video, in this part of the video. Okay, so let's draw a picture of this. Let's switch colors here. Let's draw a picture. And what we have again is a normal curve. We're centered at 0 because this is the standard normal, so we're trying to find the z-score. And I'll put in these regions. Maybe I'll choose a different color here. I'll put them in red. So these regions here, and the middle 40%. So we're saying between these two red bands here, we're trying to find this z-score here and here, and this is 40%. Okay, so that means we have 60% in the tails, which corresponds to 30% here and 30% here. Okay, so the picture that we have is really trying to come up with the boundaries, and since this is a symmetric data set, recognizing the middle 40% as really 20% and 20%, what we can do is find the z-score corresponding to, from 0 to z, corresponding to 20%. So let's switch over to our z table here, and what we're going to do is notice that the picture here, between z and between 0 and z, we're trying to find this proportion, and so that's this last column. And so let's find 20% in this right hand column, and so we scroll down. Let's maybe go keep going. Oh, right here. I don't know if you can see my cursor. So 1985, 2020, we're kind of in between here, and so maybe we'll just round over here. So we're saying the z-score is somewhere between 0.52 and 0.53. So let's just round it as 0.525. Okay, so in other words, we're saying that the z-score here is 0.52, and the one down here is negative 0.525. Excuse me. So we're looking at a z of plus or minus 0.525. Okay, let's look at a different one. Let's say, what about the tails? Let's say if I give you a condition and I say, okay, find the z-scores with 5% in one tail. Sorry, in two tails. I mean in two tails. Two tails. So again, here's our picture. Here's our z. Here's 0. We're saying that, okay, I want to find the boundary line here or here such that we have 5% between those two regions. And so we're going to split this and say, okay, that means 2.5% here and 2.5% here. Okay, so the z-score that we're looking for, positive or negative, has to be such that 2.5% is in the tail. So let's switch back over. And again, what we want to do is in this column D, we want to find 0.025. So we got to go quite a ways, I think. Oh, sorry, proportion in the tail. Let's back up here. The picture, we're looking to find this tail, and so we want to find this region, which is column C. Okay, so 0.025. 0.025. So that corresponds to a z-score of plus or minus 1.96. So that would be z, switch to a pen, z is equal to plus or minus 1.96. Okay, and you know, that's interesting. We actually use that a lot in the hypothesis testing or coming up with a level of significance. This is referencing the fact that there's 5% in both tails, so we might be using this for a 5% level of significance. Okay, let's also look at example 16. And so if we had a question that said, okay, maybe we had a average number of smiles at 62 per day with a standard deviation of 18. Okay, what's the probability that any randomly chosen person would have the number of smiles exceed 80? Okay, you can read the description on 16 and catch up. So the idea here is we're saying, okay, if our average is 62 and our standard deviation is 18, what proportion or what's the probability of picking somebody at random that has a the number of scores, the number of smiles per day exceeding 80? And so what we'd want to do first is come up with the z-score for 80. And when we do that, we find that it's going to be 18 over 18, so a z-score of 1. Here's our picture. Here's 62. We're looking at 80. We're trying to find the proportion that exceeds it, so we're looking for this region right here. Okay, so what we're really doing is sliding and stretching this graph around until we get to a center of 0 and a z-score of 1, and we're trying to find the tail probability above that. Okay, so let's switch over and find a z-score of 1. So in the column here, z-score of 1, and we're looking for the proportion in the tail, which is 0.1587. Okay, so that means 15.87% of the time a person smiles more than 80 times per day. So in other words, this region here is corresponding to 0.1587. Right? So another way to think of this is the probability of z exceeding 1 is equal to 0.1587. Okay, maybe we had a region given to us. In other words, what's the probability that the number of smiles is in between 50 and 70? Again, the basic premise is we want to compute a z-score for both of these. So find z-scores. And then what we want to do is use that to find the probability. So a quick picture of what we're looking at here. Here's our center, and again our center is at 62, and we're looking in between 50 and 70. So we're trying to find this green shaded region here. Okay, so first things first, let's compute the z-scores for both of these. It's going to have a center at 0, so the z for 50 is 50 minus 62 divided by 18. You do that computation and you wind up with negative 0.67. The z-score for 70 is 8 out of 18, so 0.44. So these z-scores, negative 0.67, 0.44. We're trying to find the region in between there. So what we're going to do is find this area and then find this area and then just add them up. So switching back over to our z-table, we're going to find a z-score of 0.44, and notice that we're looking for the proportion between the mean and z. So 0.44, 17%. So let's write that in. 17% here, 0.17. And then now negative 0.67, so find a z of 0.67 right here. And we go all the way over to this is 0.2486. So the proportion in here is 0.2486. And we add them up. Add these up and get the final z-score. So whatever you get from adding those up. Okay?